You are welcome to taptalk.com. This is Busokozibe Joseph, a teacher, chemistry. Like I told you, I've been handling you in organic chemistry, and we said at a later time I'll come in and be handling you in organic chemistry anytime from now. But for now, we are proceeding with the organic chemistry, and we have reached a level of looking at nomenclature of hydrocarbons. Nomenclature is simply a Greek word which is looking at a system of naming of organic compounds. But for now, we don't basically name all hydrocarbons at this level, but we start by naming the hydrocarbons, definitely. And not all hydrocarbons, because remember, hydrocarbons could be alkanes, could be alkenes, could be alkynes. But we basically start with the simple hydrocarbons, and that is the alkanes, in other words. Then we look at the rules of naming them. We look at their side chains. We look at a few examples, and that will be nomenclature of hydrocarbons. Now, hydrocarbons are named from, we name them from carbon 1 up to carbon 4. These ones have got their definite names which are commonly known. We know them. We know this is the alkane with 1 carbon atom. Its name is standardly known. Alkane with 2 carbon atoms, alkanes 3 carbon atoms, alkanes with 4 carbon atoms. These names are standardly known and accepted, and we can quickly name them. For example, if we are naming alkane with carbon 1, let me say with N equals to 1, this one we call it methane. Call it methane. Then alkane with carbon 2, let me say my N equals to 2, we call it ethane. Then alkane with carbon 2, alkane with the 3 carbon atoms, we call it propane. And then alkane with carbon 4, we definitely call it butane. So it is from these 4 we obtain a standard way of naming them. Remember, we are naming hydrocarbons, but in hydrocarbons, we basically look at naming a few of smaller alkanes. We derive all other names of organic compounds from alkanes. Remember we said that alkanes are parents of all organic compounds. Although benzene is a father or a parent of all aromatic compounds. So we should first of all learn how to name alkanes, so that we develop our ways of how we name other given organic compounds. So if an alkane has 1 carbon atom, we call it methane. It has 2 carbon atoms, we call it ethane. 3 carbon atoms, we call it propane. Has 4 carbon atoms, we call it butane. Now we have got a common factor among all of these hydrocarbons. That is ANE. That's a common factor on all of them. So that means this remains uniform, the only change is here. These first letters represent number. For example, M means 1 carbon atom, E means 2 carbon atoms, P means 3 carbon atoms, and B means 4 carbon atoms. That is where we name from. But if we can get alkanes with more than 4 carbon atoms, then we stop you having a specified number, but then we name according to names of polygons. We are well aware that in our pre-second or primary, we learned about polygons, we learned about a triangle, we learned about pentagon, learned about a hexagon, learned about octagon, things of that nature. So, but if it goes beyond 4 carbon atoms, then we stop naming according to the first 4 letters. I mean to the first 4 hydrocarbons, but we rather name according to the names of the polygons. Now, there's something very important that we should not forget when we are naming. When you name a given hydrocarbon, some of them could be long, that they don't have 4 carbon atoms, they don't have 5, they may not have 10, and even have so many other side chains. They have so many other side chains. We could call them alkyl groups. We could name compounds that have alkyl groups, or we can call them alkyl residues. Yeah, but the most common one is the alkyl group. So when you find somewhere it being named as residues, you should really not forget or complain so much. Preferably we call them alkyl groups, but we can also call it alkyl residues. Now, we can first of all look at general formula. In brief, just general formula of alkanes. General formula of alkanes is CnH2n plus 2. So any hydrocarbon that conforms to that general formula qualifies to be an alkane. Now, when we look at our N being 1, if we could substitute there, then we say we are going to get C1H1 times 2 plus 2, then we get CH4. That becomes the first member in the homologous series of alkanes, and the first member that we shall name methane. But now, when this first member of alkanes loses 1 hydrogen atom, it ceases to be called methane, but now becomes methyl. So this is alkane. This is now alkane, and this is alkyl group. Alkane versus alkyl group. So I'm saying that if you get a general formula and you feed in the value of N, then what we obtain is an alkane. And if it is ranging from carbon 1 to carbon 4, then its name will be standardly known. Now for this case, if the number of carbon atoms is 1, and we substitute into the general formula, then we obtain this compound. And that compound is what we shall call methane. Shall call it methane. Now, we are saying that if it loses 1 of the hydrogen atoms, it will cease to be called methane or an alkane, but will become alkyl. Alkyl is being derived from these first letters. For example, we have these first 3 letters. That is where we obtain the word alkyl. Yeah, that's where we obtain the word alkyl. Now, this one will now be called methyl. And it will be written in that format. Yeah, that's the case when, we need to know about these alkyl groups. Actually, we need to even put that to show that this carbon is lacking one of the bonds, because carbon is supposed to take a total number of 4 bonds. Now, that's the first case. This is the alkyl groups versus alkanes or versus the respected hydrocarbons. Now, suppose the number of carbon atoms is 2. we come and substitute in our general formula. We say if n is 2, then we shall have h, this is 2 times 2, then plus 2, so that we obtain C2H6. C2H6. So our alkane for that case, since it is having 2 carbon atoms, then we shall call it ethane. Ethane of general formula CH2H6, which you can also write as CH3, CH3. Because when you look at this, these are 2 carbons. These are 3 hydrogens plus 3 hydrogens, totaling to what? To 6. Now, when this compound loses one of the hydrogen atoms, it ceases to be called ethane, but then we call it ethyl. Ethyl being obtained from ethane. But for as long as it is one hydrogen less, then it is called ethyl. So therefore, this will now become ethyl. Ethyl. And then it will be C2H5, or somebody can write it as CH3, CH. Like I said, this bond simply means that this carbon is less, is electron deficient. It still has a bond it's supposed to satisfy. Now I can also look at we can also look at other alkyl groups and how we obtain them. Remember I said if we are to effectively study and understand the nomenclature of hydrocarbons, then we need to understand the general names, the first names of hydrocarbons and preferable alkanes. That is methane, ethane, propane, and butane. Then after knowing that quite well, we need to know the alkyl residues. The alkyl residues formed from those respective hydrocarbons, how they are formed, and then we shall use them when we are really looking at the details of nomenclature. So I've seen how a methyl comes about. It comes from methane, and it comes as a result of methane losing one of the hydrogen atoms. To where we don't know, and we may not need to know, but for as long as one hydrogen has been displaced, this is no longer methane, this is now a methyl. Yes, it is now methyl. When we look at ethane, we are saying it is a hydrocarbon, an alkane with 2 carbon atoms and 6 hydrogen atoms. But once it loses one of the hydrogen atoms, then it ceases to be called ethane, but rather we call it ethyl. Now, suppose we advance and go to, remember we are substituting in the general formula H2N plus 2. Suppose N equals to 3. If N is equal to 3, then we obtain CH3, CH3 times 2 plus 2, then we get CH3, C3H8. Now, this one is now called propane. And propane has 3 carbon atoms and 8 hydrogen atoms. But if one hydrogen is lost, we shall no longer call it propane. But from the word propane, then we shall derive the word propyl. So I'm saying that if we obtain an alkyl group, it will be CH3, CH2, CH2, then CH3. Or somebody can write it as CH3H7. This is an alkyl group and it is called propyl. It's called propyl. In other words, the difference and the similarity between alkanes and alkyl groups is that alkyl groups are 1 hydrogen less than the alkanes. Alkyl groups are 1 hydrogen less than the corresponding alkanes. They are formed by loss of simply 1 hydrogen atom. When we are naming alkyls, how do we name alkyls? We name alkyls looking at the alkane. We remove the ending letters A and E with YL. When we can make that replacement, then one changes from an alkane to an alkyl group. One changes from an alkane to an alkyl group. I want to give an example here. This is the methane versus methyl. That when we replace this A and E with the YL, when we make that replacement, the change is simply from this to YL. The meaning also changes. It changes from being an alkane to being an alkyl. So that is the change we make. If we look at ethane, it has this ending letters, a group of letters, but when we can replace them with YL, then this becomes ethyl. That is how we obtain that.